Okay, we're looking at the solutions to the problems that were given in exercise 5D. The first problem, find the equation of the asymptote and the y-intercept for the following. Hence, sketch the graph and state its domain and range. This next sentence is a bit of a typo, so please ignore that. That shouldn't be there. In A, we've got a function f. The domain can be any element of the real set of numbers. The range, the y values, can be anything that this rule here produces. So f of x equaling 2 to the power of x plus 5. Here is the rule that's been stated. The horizontal asymptote will be y equaling 5. And the reason for that is because there's no value that we can substitute for x that will make this first term here equal to 0. Therefore, it's impossible to get y equaling 5. So we have an asymptote at y equals 5. That's the horizontal asymptote. The y-intercept, we just simply need to substitute x equaling 0 into the rule, and we end up producing the 0.06. Our basic shape is based on the value of the base in our rule. Our base here is 2, so the a value is 2. That's greater than 1, and therefore what we're looking at is an increasing exponential. So as x gets larger, the value of y gets larger. As x approaches negative infinity, the curve gets very close to the horizontal asymptote. Looking at that information, we put in our asymptote, we put in the y-intercept, we know what the basic shape is, and we do a bit of a sketch. You can see here for our domain is that we can have anything from negative infinity to positive infinity. So that's the real set of numbers. And our range is anything above 5. Okay, notice that it's y being greater than 5. It's not equal to 5, it's greater than 5, because the curve will never reach the line y equals 5. Get close, but never reach it. Looking at our second part of the question, we've got a rule f. Again, the domain can be anything, and the range will be what the rule produces. This time the rule is f of x equaling 3 to the power of 2 minus x, take away 5. So here's the rule that we're dealing with. The horizontal asymptote is y equals negative 5. Again, this first term can't be made to be 0, therefore we can't get the value y equals negative 5. That's why we have an asymptote. Y-intercept, simply sub in x equaling 0, and this will produce 0, 4. Our basic shape, we recognise that the base of this exponential function is 3, so a equals 3. This is greater than 1, therefore we're dealing with an increasing exponential. And there's the basic of the curve there. If we look at the sketch, we have our y-intercept, we have the horizontal asymptote y equals negative 5, and we're looking at the curve, which is an increasing 1, of course. Our domain for this is x can be an element of R, so we're looking at R, or set of all real numbers. Our range is y being greater than negative 5. Part C, we're dealing with the rule f of x equaling a half to the power of x plus 3. So this time, we have a fraction as our base. See, it's just like being at school. We have interruptions of bells and announcements. Okay, so our rule is f of x equaling a half to the power of x plus 3. Horizontal asymptote is y equals 3, because this first term can't collapse to be 0. Y-intercept, sub in x equaling 0, will produce the 0.0, 4. Our basic shape. The base of our exponential function here is a half. So there's a half. The half is less than 1, but greater than 0. All right, so it's that type of fraction. This will produce a decreasing exponential. So what this means is that x gets larger, the value of y gets smaller and smaller, approaching the horizontal asymptote. As x approaches negative infinity, the value of y gets larger and larger, and it does so quite drastically, that exponential growth, as you can see there. So that's what we should be seeing as our general shape for the curve. If we put all that bit of information together, our horizontal asymptote, our y-intercept, the general shape of the curve, we should get something similar to this. Again, the domain for this function is R, set of all real numbers. The range is anything above 3, but not including 3. Thank you.